Hey guys, welcome again to the Maths Club. If you're just joining us, welcome. So for some time we've been on the series of number base. Started with an introduction to number base, then we moved to the conversion, and now we are in basic operations on number bases. What are the basic operations I'm going to be talking about? Things like addition, subtraction, and multiplication of numbers in different bases, right? So if you're just joining us, you might want to check the pop-up that will appear at the top right to take you to all of the things we've been doing in this series, right? So like we said something, or we've all agreed, our fundamental base is what? By now you should already know it's base 10. Great. So if we are going to be doing additions in different bases, we are going to start from our fundamental base, and I want you to actually keep an open mind to this, because there's something very interesting that really happens behind the scene that we might not have been taking note of. Now, we're going to start with this example, which says 323 plus 117, right? Before you start putting pen in paper, just hold on. So, 323 plus 117. We're in base 10, right? So, if I had 3 plus 7 in base 10, I'm going to get 10, right? Now, what really happens here? We divide whatever value that we get from the addition by the base we're operating in. In this case, we're operating in what? In base 10, right? So 10 divided by 10, that would be 1, right? Would that be a remainder? No, so remainder 0. Great. So it is that 0 from this division that we put here. And then we say we carry over what? Carry over 1, right? Then 2 plus 3, that is 2 plus 1, that is 3. 3 plus 1, that is 4. Also, 4 divided by 10, that is what? 0, remainder 4. So we are going to put 4 here, right? And really, we can't carry over a remainder of 0 now. 0 is empty, right? So 3 plus 1 is 4. So whenever you do all of this, right, what we are actually doing really is dividing by the base and putting down the remainder and carrying over the what do they call this itself? The result of the division, basically. Right? So let's another example. That's very easy. Let's another example. 7 plus 9, right? So let's see. So I want to add 7 plus 9 in base 10. 7 plus 9 is what? In base 10 is 16, right? So what do? We say 16 divided by 10, right? That is 1 remainder what? 6. Remember, I'll put this 6 here. I'll carry over the 1, but look at this, please. There is nothing here, right? Even though there's nothing here, we'll assume that there is like a value 0 and 0. It's just an assumption, right? And then we'll carry over 1 to this 0 and 0. So by the time we add 1 plus 0 plus 0, that will give us what? 1. And that's a 16. This thing that we've just discussed is the foundation of what we are going to be doing in the subsequent additions in various bases. What did I do? When you get the sum of the values in the base, you divide by the particular base that you are working with, put down the remainder, and carry over the what? The results. Keep on adding like that, keep on adding like that. And this division really is when you basically reach a number that is actually equal to or greater than the base. Greater than the base, right? In this case, this was 10, right? So 10 is equal to base 10. That's where really this particular thing comes in, right? This one is less than, so most likely you're always going to get the same value there, like 4, right? It's going to bother your head. But when you have like a value 16 and you're working in base 10, this division, you should check this division, right? So let's see. You will see what I'm saying in the different base. So we got 440, correct. We got 16, correct. So let's mark ourselves. This is correct. And this is correct. We are doing great so far. Now let's go to other bases, which is really the most important thing. Now there is addition in bases less than 10, right? And then there's addition in bases greater than 10. Now what do you want to do? We want to add 1101 plus 1101 plus 1011 in base 2. Let's see that. 1101 plus what? Plus 1011 in base 2. like I said, you add 1 plus 1, that is 2. That is already equal to the base we're operating in, so our division will kick in. So that will be 2 divided by the base we're working in, which is what, 2, right? And that is equal to 1 remainder what? When you divide 2 by 2, you have 1 with the remainder of what? You got it right. That's remainder 0. Great. We're actually doing very well. So what am I going to put down here? I'll put the remainder, right, which is 0, and carry over the result, which is what? 1. 1 plus 0 is 1. 1 plus 1 is 2. So it's still the same thing, right? So I'll put down 0 and carry over 1, right? 1 plus 1 is 2. 2 plus 0 is 2. Still the same thing. I'll drop down the remainder, right, and carry over the 1, right? So before I do this one, do you want to pause the video and try what this particular thing will give you? Great, welcome back, right? So this is 1 plus 1 is 2. 2 plus 1 is 3. So that would be 3 divided by 2, right? When you have 3 divided by 2, what would that give you? 1, right? Would that be a remainder? Perfect. Yes, there will be a remainder. A remainder of what? Of 1. Great. You're doing very well. So 1, right? I'll put down the remainder. Just like in the case of where we add this particular guy, right? 7 plus 9, where we add 1 remainder, 6, 6, 1. So we're going to put like an imaginary 0 value behind it. So you might not need to put this in your notes, but I mean, just for I'll just put this imaginary, but in your mind, you should put it in your mind, really, not on your paper, right? So now I've put down 1, so I'll carry over 1 to this 0 and 0. So 1 plus 0 is 1, 1 plus 0 is 1. So the answer here is 1 1 0 0 0. What did we do? We added. Whenever we have a value that is equal to or greater than the base, we come and do this division, right? So this was 2. 2 divided by 2, that was 1 remainder, 0. We put down the remainder, we carried over the 1, the results. 1 plus 0 is 1. 1 plus 1 is 2. 2 divided by 2, still the same 0, carry over the 1. This is still the same 0, carry over the 1. But here we add 3, right? 3 divided by 2, 1 remainder, 1. We dropped 1, right? We carried over the other 1. We assume that there will be an imaginary 0, right? Because if you look at it, 0 5 is also the same as 5, right? And 0 1 is the same as 1. So if I put a 0 behind 1, it doesn't change anything. It doesn't change the value fundamentally, right? So that's why I put 0. So if I say 1 plus 0 plus 0, that gives me what? Gives me 1, right? And that's how we actually add in a different base. So I said that we should hold on and take note of what I was doing there. Great. So we are doing very well. Now let's look at this thing. Whenever we have like more than one division, more than one addition to make, we take it step by step, right? Just like when we see we have 4 plus 14 plus let me improve on my writing, plus 256, right? You don't just add all of them. When you say 4 plus 14 first, then you now add the value to 256, right? So that would be 18 plus 256. Then when you now resolve it, you now get a final answer. So it's the same procedure we're going to use here, right? Let me move to a new blank sheet. So 421 in base 5 plus 12 in base 5 plus 42 in base 5. Yes, so we're going to take it step by step. So let's start with 421 in base 5 plus 12 in base 5. Right, so you want to pause the video and try this simple addition by yourself. Welcome back if you tried it out, right? So let's solve it together. Remember, we're working in base 5. So 1 plus 2, that's 3. 3 is less than the base, so we can just write the value 3, right? 2 plus 1 is also less than the base, which is 3, right? So I'll just put the, and then our value, what? Our value 4. You know, we can assume that there's a 0 here, right? That is adding, that I will add here, so that will be 4, right, in base 5. So we are done with the first half of this addition, right? And that's very good. Now we're going to add what? 42 to it in base 5. Right, so that's the next addition that we're going to do. Now that we've resolved this two, let's add this last part. So as we did before, you might want to pause this video and try it out yourself. Welcome back. right? So let's add. So 3 plus 2 is 5. Have we reached the base, or are we above the base? Yes, we have. So 3 plus 2 is actually 5, right? So and our base is 5, so we'll do our small division. So 5 divided by 5, that's what? 1, remainder what? Remainder 0. Great. So what will I put down here? Will it be the 1 or will it be the 0? Perfect. I'll put down the 0. Great. So let me put the base here. So and I'll carry it over 1. So 1 plus 3 is what? 4. 4 plus 4 in base 5 is 8. Right? But 8 is already greater than 5. Right? So what will I do? Great. I'll do my log division. So 8 divided by 5. 8 divided by 5. What will be the value? The value will be what? 1. Would there be a remainder? Yes, of course. There will be a remainder of what? Of 3. Right? So what am I putting down here? Am I putting down the 1 or am I putting down the 3? Perfect. Right? So I'll put down the 3. Right? And I'll carry over the what? The 1. Great. So like I said, there can be an imaginary 0 here. So 1 plus 4 is what? 5. Have we hit a value that is equal to the base, greater than the base? Yes, we have. Right? So 5 divided by 5 is still the same. So what are we putting down? We're putting down 0. And we're carrying over what? Carrying over 1. Right? So remember I said there's an imaginary 0 that will add up this 1. So basically we're just bringing down the 1. So at the end of the day, our addition of these values in base 5 is what? 1030. This is basically it about adding in a different base or in all the bases. But most times we don't really take note of this division, right? And that's where I feel like the problem actually comes in. It's actually very simple, right? So you do this, right? Let's first check our answers if it's correct. 11000 in base 2, which is exactly what we had. 11000 in base 2. So yeah, we can score ourselves and say we did very well. Great. So the same thing. So 1030 base 5. Let's see what this is. 1030 base 5. I think that's what we actually got. Great. That's what we got. So this is basically how we actually add in different bases that are less than. I mean, when we know the bases and then the bases are less than 10, right? So let's solve one last question before we call it a day, right? So this is 774 plus 447 plus 113 base 8, right? So let's see. Let me move this a little bit. So 774 base 8 plus 447 base 8 plus 113 base 8. Great. So like always, you might want to pause the video and try it out yourself. The taste of the pudding is in the eating. Right? So let's solve it, right? So welcome back. So 774 base 8 plus 447 base 8. Let's solve this. 7 plus 4 is 11. 11 is definitely greater than our 8. So 11 divided by 8, right? That will be what? 1 remainder 3. So I'll drop 3, which is the remainder. I'll carry over 1. 7 plus 4 is 11. 11 plus 1 is 12, right? So 12 divided by 8, right? That is what? 1 remainder what? Remainder 4. So I'll drop the remainder and I'll carry over the 1. 7 plus 1 is 8. 8 plus 4 is 12. The same thing. So I will write 12, carry over 1, an imaginary 1, which I will bring down, right? With an imaginary 0, right? Which I will bring down, right? So we are done with this first part. So if I do the second part, which is 113, right, in base 8, 3 plus 3 is what? That's 6, right? So 6 base 8, right? 4 plus 1 is 5, right? 4 plus 1 is 5, and this is 1. You see, I didn't bother to do the long division because it was not up to 8, right? So that means the sum of this, our addition, is going to be what? 1556 base 8. 1556 base 8. Is that what we got? That is what we got. Yeah. So we are actually good. So we've talked about adding in bases less than 10, but you've noticed something. All of the bases here, they were all uniform. Base 2, base 2, base 5, base 5, base 5, and all of that, right? So in the next video, we're going to talk on where there is a mixture of bases. For example, let's say this is base 2, right, and this is base 8. So how are we going to do that? We'll touch on that in the next example. Also, next example, like this is not the only way to actually add these bases, even when they're uniform, right? So you can convert to base 10, you can convert each of them to base 10 and then add, but I strongly do not recommend that, especially if they are in the same bases, right? But we'll also touch on that second method. So see you guys in the next video. Please don't forget to like this video if you found it interesting. Subscribe to our channel so that you'll be up to date with all of our contents, and comment if you have a question, or if you want to say something, anything at all, just feel free to express yourself. See you guys in the next video.